Okay, guys. So this is gonna be a short video where I'm basically telling you where you messed up on the assignment 2 and assignment 3. I'm not gonna try to solve anything, but just tell you where to be more careful in the future. So I guess first of all, is f is when what is f of t? You know, what is f of t and what is f of t, and basically how does it translate into integral from 1 to t fs ds? Okay, and this has been a problem, and it caused trouble into N3, where people had, this is from seminar 2, from assignment 2, and then you have assignment 3, where you had something of the type integral of q t plus p over e dt. It's really careful. Whenever you see such a parentheses and you're given a function, it's written like a function, you have to consider they're not a constant. Like this was a total mistake, and it can obviously cost you the whole problem really easily if you just take q as being a constant. The idea is when you were told that q antiderivative of small q automatically means q is a function, okay? And if q is a function, then it means that, hey, this means just q applied to t plus p over e. Okay, so really important, caused a lot of mistakes in some people that would have else solved everything perfectly. So really careful on this. Now, that's the first one. Second observation is when you're doing integration by parts, this would be like first. And in order to call it, it's like, is it a function? Is it a constant? Just be careful what you choose, okay? If it looks like a function, treat it as a function. Don't take it out and think about it. If you're a little bit confused on the exam, which is basically the only reason we're talking right now, is ask on the exam. Just ask. And you know, the guys that are gonna be supervising can probably confirm, hey, it's a function, okay? Or give you some hints why it might be a function, okay? Now, moving on. Second, when you are applying by parts, and I notice that most of you are starting to become kind of proficient on it, so you're doing it fast in the sense that integral from, let's say, a to b of f prime x gx dx plus integral a to b of fx gx prime dx is equal to, not this one, it's f of x gx from a to b. Okay, and the way most of you are writing it, which is perfectly fine, is just ab f prime of x gx dx is equal to fx gx ab minus ab of x. Yeah, perfectly fine to apply like this, but be really careful when you are applying by parts to a definite integral. Do not forget these heads and the integration. There have been, I guess, more than 50% of the papers had stuff like would give me a result of the integral that had both t and s in it. So really careful here. Always remember about the heads of integration when it's a definite. Okay. Now, talking about heads of integration, this brings us to the next one, which is number 3, substitution. Okay, Substitution. Why am I going to talk about this? Well, because although you got the right answer somehow, and again, I'll make a parenthesis here. If you think you have fooled me, you have not, because I've seen some equations that made absolutely no sense, but you have somehow got the right answer. At which point I either did not comment it, or I just said mistake computation or something like that. At which point it meant I'm not gonna bother into going into something that you know is wrong, but you just try to fool me. Okay. Substitution. When again, most of you when you had to do it in the indefinite integral. Let's talk when you had to do in the definite integral, which was the integral log of t dt. When you replaced this, most of you, let's just say you used x is equal to, I think it was, you were supposed to use this log of t, then whatever dx dt is equal to 1 over t, okay? From here, you'd have t is equal to, you know the solution by now. And I'm trying not to be, not to dive into this because this is not what I wanted, what my point is. My point is that most of you just wrote stuff like dt. From here, you'd have dt is equal to t dx. And most of you just wrote stuff like this is equal to x multiplied by, because this was x multiplied by t dx, and you start solving me this, okay? Again, remember, you cannot have apple and oranges under the same integral. You need to have everything in terms of x. And this, and most of you tried to solve me this and try to convince me that it's correct. No, you can't have this. Can't have this. If you want to write this as an intermediate step, that's fine, but you cannot have this as the final answer. The final answer is suppose integral x e to the x dx. Everything depends on x, okay? Important mistake. 50% of you or more missed this problem, which was literally a two-liner. And on the exam, it might cost you. Cool. Now, fourth mistake would be, let's see. Fourth mistake would be still on substitution. Substitution, as it says, always proved kind of hard. So let's see what we can do about it. Substitution, would be 4. Substitution plus limits of integration. Okay. Most of you, and I think you had the integral from 0 to 8 e to the minus z1n, whatever, something like this. And then most of you did the substitution correctly and whatnot. But what you did not change was were these. You did not change 0 and 8. Okay. And I've seen there's kind of a theme of this. What you do is you either do the computation, ... do the computation, etc., and then you get like as I don't know, you get, let's say, just say you get at a function. Okay, let's just do the short replacement. Let's just say u was minus z to the power of n ... I'm not going to do all the computation again. This is not about doing the computation. You have the solutions in the seminar and etc. This is not about computation. It's about what you did wrong, and what happened was you had this, and then you have, okay, this integral 0 to 8 of. And the problem is you kept u here. You had a function of u here, du, okay? And what I've told people is at this point, you are not adding from 0 to 8 anymore, okay? What you're doing is you have to change. So for example, z equals 0 means u is going to be minus 0 to the 1 over n. Z equals 8 means u is going to be minus 8 to the 1 over n. Okay? So with these replacements, your integral should have been minus 0 to the 1 over n minus 8 to the 1 over n f of u du. Okay, now you're going to say, hey, I didn't do this, but I still got the correct result. Yes, you did. Some of you did get the correct result in 7 days with time and being able to check the internet and whatnot. I'm not saying that you did, and personally, I don't care if you did. But on the exam, the problem is that eventually you get like this is equal to an f of u. And then what you do is you replace this. You say, hey, this is just f of minus z1 over n. Okay. So my integral 0.8 ez minus 1 over n ez is going to be equal to f of, what is it? Let's just say minus 8, 1 over n. Minus n minus f of 0 to the 1 over n, okay? And you write this, and it's I guess it's correct, but the idea is that if you want to do it like this, you have to, you either have to, like, you can't keep the limits of integration and then just randomly replace them. So the way to address this is, first, you either change the limits of integration and then you get, let's just do this example, minus 1 over n minus 8 over 1n fu du is equal to big F of minus 0 over n of, let's 8 here first, minus f of minus 0, 1 over n. So the idea is that if you change the limits of integration, you don't need to replace back in a definite integral, okay? You don't need to replace back in. You either change the limits of integration and you don't need to replace again, or the second case is you compute the indefinite integral. So you can write as indefinite that e minus z1 n dz is equal to, again, if you don't change the limits of integration, don't change them at all, because you can't write 0.8 here. It's going to be a huge mistake. Okay, fu du, this is what, like, u, the change of variables. And then you solve this to being an f of u plus a constant, okay? Okay, and once you do this, now you go all the way back and you say, okay, so integral of e minus z1 n dz from 0 to 8 is equal to f of minus 8, again, I mean, it's f of minus z to the 1 over n plus a constant. I mean, without the limits of integration first, let's say this is the primitive. So if this is the primitive, then I can write from 0 to 8 of e minus z1 over n dz is equal to f of minus, and now you replace okay? So two ways, but don't mix them up, because while I didn't care about the mistakes and I may have not written them out, they are pretty big mistakes and some graders are not going to take into account. So you either change the limits of integration, okay? And when you do the limits of integration, or if you change the limits of integration, this is an 8. This is an 8, by the way. It's supposed to look like 8. If you change the limits of integration, then you don't need to replace back, and you can just replace with the new limits of integration. You're going to get the correct result. Or you use substitution to compute the indefinite integral, okay? The indefinite integral. And then you compute the indefinite integral, and then you replace, okay? But do not mix them up, because in an exam, you might forget to replace. If you just carry the 0 over 8 and replace, you've got to, and you replace, for example, here, you're going to get something completely different. You might as well lose track. So stick to one approach, okay? Both of them are correct, but do not combine them. Now, second observation, or like fifth, I think at this point, I don't know, let's make it like fifth. The fifth observation I can give you is, do not forget about the constant. So integral of f of x dx is equal to f of x plus constant. Okay? It might seem really minor, but when you're doing differential equation, when you're going to solve differential equations, if you're not using the formula and you forget the constant, you're missing a ton of solutions, okay? So do not forget about the c. Also, same parentheses, no need to put c in definite integrals. What do I mean by this? Is if you have this, and I'm asking you to compute from 0 to 1 f of x dx, you don't need to write f of 1 plus constant minus f of 0 plus constant. Okay, you don't need to write this. You can just write f of 1 minus f of 0. Okay. Cool. Now, I think this more or less covers all of them, and I think I overextended a little bit, already a little bit more than I wanted to. Okay, one more really important, which destroyed here and destroyed on the others on assignment 2, was difference between f prime of 1 and f1 everything prime. Okay, really, really careful here. Okay, and I'll show you the example. Let's just take a simple example. I don't know, f of big F of x is equal to x squared. Okay, f prime of x is equal to 2x. Now, let's see. F prime of 1 is the same as, let's call this f prime of x is equal to just small f of x, okay, derivative. When the prime is here next to the function, it means that you are referring to the derivative of the function applied to the value 1. So this is equal to f of 1, which is equal to 2, okay? Now this is f of 1, the value of f of big F applied to 1, so 1 squared, everything derivative, okay? This is a constant, so this is going to be 0. As you can tell, these two are completely different, okay? And this was the problem in h equals f of t. It was the problem here as well on the one that asked you to take something from seminar 2. Again, this is I think one of the biggest mistakes, easiest to make, but extremely, extremely big from a point of like understanding the problem. What is the difference between these? Now, other than that, I don't think there were any other big noticeable mistakes. Oh yeah, of course. Okay, tips, tips and tricks on point J. And I think I said this. They asked to show that it is a particular solution. show particular, so show that it is particular solution. Most of you got it right, but there were a lot of cases where people just started computing me the general equation and getting me the C. Yes, you can do it like that, but show in this case, you can just compute x dot, which is just dx over dt, and replace. Okay, this is exactly the same logic as the last point on seminar 2, on assignment 2, which was show this integral. You can take the derivative if the problem doesn't specifically tell you show by anti-differentiation or do not take a derivative or etc. You can always take the derivative of the right side to show the left side. Okay, you had like you had in assignment 2, you had integral of something has to be equal to this, okay, plus a constant. You can take a derivative of this, okay? I don't know, if you're not actually convinced, the problem was here, all right, 4x squared plus 2 squared minus 1 dx is equal to log of 1 minus 2 x2 plus 3 plus a constant. You can take a derivative of that and make it, take a derivative of that, make it equal to this. Okay. I think these were most of the mistakes that I've seen. Hope it helps. And if you have any other questions or there are any other mistakes or any other questions that I missed, just let me know. But I think this is gonna be it for me. I just did it now because they're kind of fresh in my head. But generally, I think everyone did a good job on the assignments. The mistakes that were made were not so impactful, and I think you're all in a pretty good spot, I would say. So congratulations, and you know, if you make these small tweaks, then you're gonna be in a good spot. So yeah, I'll catch you guys later.